Hello and welcome to episode 5, Programming with Matt, dropping objects and frames. What we'll be doing in this episode is just placing some objects into our level. This will include mainly trees, and then after that we'll be looking at the rendering function to just try and see if we can make that a bit more efficient and hopefully increase the number of frames per second we're getting. As you can see here, I'm making the object tree. I've already made a package called objects and a class called objects. This will be where most of the information is stored. However, as you can see, I'm using tree here, as each object will have its different class, and this will make it easier to manipulate the way a tree works and the way a fence works, for example. So change it to Enviro objects. This is just because the object is already a keyword in Java, which means I'm unable to use it. And all object means, it means in general just what all of these different ones are. If you call an object, you can store any of these in an object. What you see here is me just setting up the render function for the object, and this is just the same function I've been using all the time really. As you can see, I just make sure that the pixel is on the screen and then render it. The next thing you see me do is I make the tree in the game file. I place it where I want it. I've got set up a constructor, and I just do that and just set the level X and the level Y positions. I then tell it has to render, and obviously I have to send it the level coordinates just because this is how I have to do it, so that I make sure I place it on the level. And as you see, it doesn't work. I look at why it doesn't work, and as you can see, I was halving the screen every time. So I was making sure it was in the top left quarter of the screen, sorry. As you can see, that time it did actually work. Now what you see me doing is just redesigning the tree. I do this a lot of the time as it just didn't look right. It was really small. It was only 14 pixels high when the person that's walking around is 28 pixels, so it would be taller than every tree. What you see here is me just making it 28 high, and I'm making it 32 wide. And as you see here is me trying to get the look right so that it becomes an actual circle, not a circle, sorry, more of a oval. As you see, I get all the way around to the top and I don't like it. Now decide now that that's how I want it to look. I will redesign the tree at some point, but for now this works, and it means that I can work with the tree and I don't have to worry too much about design, because I can always do that at a later date and just change the images, and then there'll be no extra coding because all the coding will already be there. It'll just be a matter of changing the image. As you can see there, I just had to change the size of the image in the code, and there you go, you can see the trees rendering. The next thing we have to do, however, is go into the entity class and tell it to invalidate properly. What we're doing here is, as you can see, I've made a new function called invalidate chunk. Now what this will do is this will invalidate a certain square around the player, and this will just tell it to invalidate that little section. And as you can see here, I'm setting up where the middle point of the player's image is. This is just because I can pass it that and then send it 80, which means it will render 80 pixel square from that point. So this, as you can see here, we tell it that inval chunk is true. This will just tell it that it has to only redraw a little chunk. And the next is a variable called chunk to inval. And now what this will do is, as you can see, it just uses the middle point, and the two x's is the middle point minus the radius and plus the radius, and the two y's the middle point plus the radius and minus radius, just in each direction. So what we made is we've made a 160 by 160 pixel square, and in the level we use this to figure out what tiles it has to reproduce. What you see me doing here is just setting up the render function for the invalidate chunk. And what you see a moment ago was me making a chunk class. This is just so that it can hold 4 variables and it keeps it nice and neat for me. And as you see before, I was just accessing each of them by the name of the chunk, which in this case is chunk to inval, and then dot, and then XO, YO, X1 and Y1. What you see me doing here is just setting up the square of tiles that it has to reproduce, and then I put them into my rendering loop so that it knows it's them ones it has to render. Tell it to it's false, it has to invalidate the chunk now after it's rendered, and as you can see we're getting a lot higher frame rate now. It's almost doubled actually. So what I do now is I go into the game and I have to set up a new rendering function. To do this, we have to go into the object manager, and we just make a static tree as opposed to keeping it in the game class, and then we'll also make a render function, as you see, and that will just render a tree that we set before. Now you see render strip. Now what this will do is we will pass it a screen strip, and what this will do is it will figure out where on the screen each of the objects we create are, and then only give us the objects where the bottom of that object is on the certain strip that we send them. Now the good thing about this is, as I was saying about the rendering improvement, we have to cycle through the screen. Now the screen has 640 pixels down, and what we will be doing is cycling through each of them 640 pixels individually, and we will then render each of them strips individually. What this will allow us to do is, as the player walks closer to the bottom of the screen, this will tell the game that he's actually further forward than any of the objects above of him, and you'll see that in a moment when we finish. What we're doing here is I'm making a function called getBottom in the object class, and what this will do is it will just take the object and it will take its X position on the level, and it will add the height of the object to it, and what this will do is it will tell us where the bottom pixels are, and next thing we do is we store the width and the height within the function separate in the environment objects class, as opposed to the tree class has all of objects will have to have a width and a height. Next you see is PS, which is the player's position on the screen. The reason we have to have this as well is for the same reason as the trees. It just gives us where its feet are, and therefore how far forward or back into the level it is. What you see here is starting the loop from LY and then finishing at LY plus the engine height. What this will do is it will give us the levels position, and it will start the loop at the levels position, and it will finish it at the levels position plus the size of the screen. This allows us to create a loop of 640 while keeping the numbers in relation to what they're meant to be. What you see now is just me setting up in the players class the different function, the getBottom function, and now as you will see the player starts but it doesn't go right. I spend a lot of time troubleshooting here. As you can see, I go to the bottom and I figured out for X instead of Y, and it still doesn't work. So next I try the game class, and as you can see by the pausing that I'm thinking about what I'm doing. I'm printing out the player's X position, and also I'm printing out the different the screen strips that it's drawing, and you can see now that it actually works. When he's behind the tree, he's behind the tree. He's being drawn behind the tree. When he's in front of the tree, he's being drawn in front of the tree. Which this is obviously what's meant to happen. Next thing I do is I'll just create a few more trees, and we now got 3 of them. And as you can see, it doesn't work at all. This gets really frustrating for me actually, because all the time I'm sitting there doing this, it just keeps going from working to not working, and I'll let you watch as I troubleshoot it. So I decide that I'm going to print the objects level Y and screen strip that is being sent. Now, as you can see, the level Y and screen strip were just printed individually, just next to each other, and so it's coming out as a really big number, and that's why it wasn't working right at first, and so I had to just put them into brackets so they added them together instead. What you see here is me just separating them side by side, and you can see there what I meant before about as you move the level around, the player jumps from behind the tree to in front of the tree without the player actually moving. What you see me do here then is I take out where I'm printing the positions. Then what I decide I'm going to do is I'm going to print the top position and the bottom position of where it's rendering, just so you can see the gap that it's meant to be rendering in between. Next thing I decide to do is just print the position of the player's feet, and then in render strip I decide I'm going to print what strip the objects are printed on. As you can see, it clearly says that the positions are different, and that the player is actually meant to be behind the tree. What I then decide to do is just set it that the object manager actually returns whether or not it drew an object. This way what I can do is, as you see, I've got 4 different variables there. 3 say object, 1 says player. And what this will do is it will tell me where the player is, and therefore it will also tell me these will be drawn, or written, sorry, in the order that they are rendered. This way you can see this is just a text version of saying that the player is now behind the object. What you see here is I make a new thing to print called this one, as I have so many printing now that I need to know which one I'm meant to be looking at, and I don't want to remove them from printing because they could come in handy in a bit. And what this does is it just tells you the bottom of the object, and I then decide I also want it to tell me whether or not it's equaling the screen strip that it's trying to render. And then what I do instead is I decide that I'm going to put the other way around, so if it equals the screen strip it's meant to render, then it prints out what the variable is. And as you see, I'm looking around and I don't know if you see, but I was sending the level Y. I was already adding it to the screen strip in the loop, and then I was also adding it a second time. And as you can see, when I do that, the player now renders correctly, and he's walking behind trees when he's meant to walk behind the trees. Next thing you see me doing here is just creating a new image, and this will be an image that I've created already. And what this image is, it's called test object. This is an image that stores different colours in the same way our level stores different colours. Each of them different pixels will represent a different object. And as you can see here, I'm just creating a loop to loop the entire image, and then once it's looped the entire image, each individual pixel, it gets the colour data for that each individual pixel, and then it tests to see if it equals the colour of the object, and if it does, as you can see here, we're telling it to add a new tree at the position, and then we also have to set it for make sure that it collects the right colour information. As you can see, we just put a get width in the image class and a get height because we didn't have them already, and then when you render it, you see we now have a forest, as this is the image that I decided I was going to draw. It was just a little forest. As you can see, the player walks through it correctly, as he should, which is good. Next thing I do is I make just a dirt mound, and this was an idea I had quite early on, that I want to make a little lump of dirt basically that will show you that you can dig at that spot. And so that's just what I'm putting in now. I make the dirt mound class, I just copy the same as the tree because it's near enough the same information, just with a few different numbers, As you can see, I've drawn it on the wrong layer, so I'll draw it on the right layer, save it as it's meant to, and then when I run the game, you'll see it comes up perfectly. Okay, that's been episode 5, dropping objects and frames. Please check back on Wednesday when you will see what we're doing then. Thank you.